go. The question is, if I'm seeing it right, it says x ey minus 10x plus 4y equals to 0. Find dy dx using implicit differentiation. You really can't solve it for y, so you have to use, they don't have to say use implicit. Again, explicit, when you can solve the problem for y, then take the derivative. We can't solve that problem for y. It won't be easy, it won't be pretty. So implicit differentiation is the way to go. How do you find dy dx? So that's what the question. Well, let's look at this one first. You have a multiplication. X times e to the y. So when you take the derivative of that, we have to use what rule? Product rule. So the first times the derivative of the second. What's the derivative of e to the y? E to the y times the derivative. Remember, the derivative e to the u is what? E to the u times u sub prime. In case you forgot. It's u sub prime times e to the u. So what is the derivative of, that's u. Y is u. What's the derivative of y? Times dy dx. So it's the first times the derivative of the second plus the second, which is e to the y, times the derivative of the first. What's the derivative of x? 1. So this answer, what you see here, all of this is actually the derivative of that. Product rule, the first times the f times g sub prime plus g times f prime. Here's the minus sign. What is the derivative of 10x? There's the 10, yep, I already have the minus. And there's the plus, the 4, what's the derivative of y? Dy dx. And now you want to solve it for dy dx. So we're going to look for all the terms that have dy dx in them and move them to one side. And take the rest to the other side. So that will be, if I factor dy dx out of the group, what's left in the first one here? Is it x times e to the y? And there's that plus 4 equals. Now, when I grab that negative 10, it doesn't have dy dx. I'm going to take it to that side. And I'm going to take this to that side. When I take it to the right side, this becomes what? 10 minus e to the y. Can we solve for dy dx? 10 minus e to the y divided by what? X e to the y plus 4. Which problem is this? 3. Yep, that's the answer. They left it just the way you see it here. The only thing I see different, they have a dot here between x and y, e to the y. They put a dot when you type it. That was 3. 4 is the next one on the list. If you have questions, don't be shy. Ask them. This is number 4. EXY plus x to the 5th minus y to the 5th equals 20. Again, just a reminder, the derivative of e to the u is u sub prime times e to the u. This is my u right here. That's my u. So the derivative of that is going to be the derivative. I'm just going to write the derivative, and I'll come back and find the derivative. The derivative xy times what? E to the power of xy. It says u sub prime, or the derivative of u, times e to the power of u. What's the derivative x to the fifth? 5x to the fourth. There's the minus. What is the derivative y to the fifth? 5y to the fourth times what? dy dx. And the derivative of 20? I didn't take the derivative yet of this one. It says u sub prime times e to the u. Well, let's take the derivative of u. You have x times y. So what method are you going to use? Product rule. The first times the derivative of the second, which is what? dy dx. Plus the second, which is y, times the derivative of the first, which is what? Or 1. All of that is going to be multiplied by ex to the power of xy. Now, if we distribute this one, we will have x e to the power of xy dy dx plus y e to the power of xy plus 5x to the fourth minus 5y to the fourth dy dx. I want all the ones with dy dx in them on one side. So let me take this one and move it to that side, and let me take this and move it to that side, because they don't have dy dx in them. So if I factor dy dx out, we have what? X e to the power of xy minus 5y to the fourth. What's on the other side? Minus 5x to the fourth minus y e to the xy. What's dy dx? You can pull a minus outside, right? Because they both have a minus in them. So if you pull a minus outside, it would be 5x to the fourth plus, because I took the minus outside, factor it. Now me personally, if that was me, I take that minus sign, it's on the top, I put it on the bottom. Instead of having that minus sign, so if I moved it to the bottom, guess what the answer is going to look like? 5x to the fourth plus y e to the xy. When you bring that minus to the bottom, it's going to change all the signs on the inside. It's going to make that 5y to the fourth minus x e to the xy. They probably leave that answer there, your book. I don't know. Let me see. Yeah, they left it like this. But you can take that minus sign, bring it to the bottom, distribute over this. You're not carrying all these minus signs. Just flip that one. I guess they like e to the u there. So the next one is not. Number 7. Y equals sine of xy. Now again, let's remember this one. The derivative of sine u is what? It's u sub prime times cosine of u. It's the cosine of this one times the derivative of that. So this is my u. Let's take the derivative of both sides. What's the derivative of y? dy dx. All these questions find the derivative. What's the derivative of this? Well, it's going to be the derivative of xy, because that's u sub prime, times the cosine of u, which is xy. So it's cosine xy times the derivative of xy. What's the derivative of xy? We just did that. That's the product rule. The first times the derivative of the second plus the second times the derivative of the first. Distribute that. dy dx equals x cosine xy times dy dx plus y times cosine xy. All the ones with dy dx on one side, and let's factor the dy dx out. What's left? 1 minus x cosine xy equals y cosine xy. And dy dx now, last step, is going to equal 2 y cosine xy over 1 minus x cosine xy. Y cosine xy, 1 minus x. Again, the only difference when I look at the solution, they put dots here to show multiplications. That's the only difference. They put the dots. But that's the answer they have. Any question on this one? Go ahead, George. You're looking at it. Something is bothering you. I move this one to this side, so that becomes a minus. I don't know if that's what you did.
Where'd the 1 come from?
When you factor dy dx, so that's dy dx times 1, right?
Okay.
So when you factor that out, you have a 1 left there. Anyone else? Am I going too fast today? Sometimes the caffeine kicks in late. I don't know. Nothing.
It's a little tough to grasp.
This is the fun stuff. It is different because you have to get used to dy dx.
Yeah.
That's the part. Sometimes actually as a practice, just write dx dx. So just a reminder. I got to keep dx 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 all the time. You know. But once it clicks in, eventually will click in. Once it really clicks in, oh, I see it now, boom, boom. Eight. I have x equals secant 1 over y. Again, just a reminder, the derivative of secant u, not x, u. Derivative of secant is secant tangent. But since that's a u, that's not an x, times what? U sub prime. The derivative of secant is secant tangent. When it's u, you always got to multiply your answer by u sub prime. So let's take the derivative of both sides. The derivative of x is what? 1. The derivative of secant, it's secant 1 over y, tangent 1 over y, times the derivative of 1 over y. That's the u prime. You can take the derivative of u. Now, if you want, actually, you can use the quotient rule here, but you don't have to, because if you rewrite that, that's y to what power? Negative 1. Instead of the quotient rule, that'll be easier. So what's the derivative of that? Minus 1, y to what power? Negative 2 times dy dx. And you can rewrite that minus 1 dy dx over, I can write this minus dy dx, the whole thing divided by y squared. Now when you look at that, you get that little ugly fraction right here. That's all multiplication. That's all one term. What will happen if I take that equation, multiply this side by y squared, and this side by y squared? Do you see anything that might cancel? The y squared will cancel. Right there. So you get y squared equals, I have a minus sign in the front, I'll put it in the front here, secant 1 over y, tangent 1 over y, dy dx. I took the minus in the front. Can we solve for dy dx now? I'm not really a fan of having a minus in the bottom. So instead of putting the minus in the bottom, I'm going to put the minus where? On the top. Because when you have a fraction, the minus can go in the front, on the top, or on the bottom. So you can put it in the front if you want to. Which one is this?
That was
8. They have a multiplication instead of division.
Say what?
The answer is actually I have multiplication, negative y squared. Instead of dividing by this, it's negative y squared times secant 1 over y tangent 1 over y.
Yeah.
Let me just double check it. That's a 1. Derivative of secant is secant tangent times the derivative of this, which is no, that should be division.
No, I know that it accepted the negative y squared over secant 1
You did?
over y tangent
Oh,
1 over
okay.
y, yeah.
Maybe there's a just, oh yeah, there's a line. Okay. I just didn't see it. At least I know I'm right. I'm like, oh, I'm looking at it.
I was about to be really confused.
Yep. Okay. That was 8. I feel, we're all human. We make mistakes, so maybe I did make a mistake. Let me just double check. Number 9. Scroll down. I have x squared minus 9. The natural log of y plus y squared equals 13. I know what the derivative of the natural log of u. It's used to prime over u, but it's nice to have the book handy. Those equations. Right on the cover of the book. The derivative of the natural log of u. It's used to prime over u. That's what I'm going to use. Because you see natural log. Huh? That's in the cover book, the cover page actually. I'll take a snapshot. I did last time, it's in the notes actually, but I'll do a snapshot when I do the notes differently, PDF file. I'll take a snapshot of this too. That's the cover of the book. All calculus books have that. They put a cover page that has all the derivative, all the integration, all the trig identities, so you don't have to keep thumbing to see where they are.
Didn't you say you were gonna?
Oh, you can't get the notes. Oh yeah, you can't get the other ones.
You said you were gonna make a photocopy of that?
I forgot.
Oh, okay. I thought you already did and I missed it.
No, maybe I'll do during the. I'll see if the math center is still open. The copier. The derivative of.
Did you do the digital book, or
Yeah, I do.
it's right on
Oh,
the
it
second
is?
page of the
Yep.
book? Yeah.
Yep.
Oh, okay. Thank you.
No problem.
The derivative of the natural log of u. Can you print that? George, can you print that pages? Like if you were to print a page,
yeah.
you can?
Yeah, it'll just say something like it has a watermark.
Okay. So it's used to prime over u.
Actually, email you the PDF.
So now here we go. The derivative of x squared, which is what? 2x. There's the negative 9. What's the derivative of the natural log of y?
It'd be 1 over 1.
Well, it won't be 1. What's the derivative of y?
It'd be y prime over y.
Yep, y is a prime over y. Yep, that's dy dx. That's fine. It's cleaner this way. Plus, what's the derivative now of y squared?
2y times 1 prime.
2y times dy dx, or y sub prime. It's the same thing. And what's the derivative of 13? 0. Oh, that's what you asked me about where the y squared came from. You were talking, right?
What is that?
Is this the question? So they have y squared instead of y?
Yeah.
That's because, notice you have a fraction. To get rid of the y in the bottom, we're going to multiply the entire equation, every single term, by y to get rid of the fraction. That's the best way to cancel a fraction. You multiply by the LCD. What's y times 2x? 2xy. Minus, what's going to happen to this y and that y? Gone. 9y sub prime. Plus, what's y times 2y y sub prime? 2y squared times y sub prime. And what is y times 0? 0. I can move the y prime to that side. 2xy will equal what? 9y sub prime minus 2y squared y sub prime. Take y sub prime out. 9 minus 2y squared. And what's y sub prime? 2xy over 9 minus 2y squared. So I think that's the one you were talking about, right? Where the y squared? Yep.
I get why we took, or we multiply the whole thing about y by y, but is that necessary? And
Well, if you didn't, you're going to have 9 over y here.
mhm.
You'll have 2x equals, like if you didn't do that, you will have 2x equals 9y sub prime over y minus 2y y sub prime. So if you factor y sub prime out, you'll have 9 over y minus 2y. And what's y sub prime?
Minus prime would
2x
be 7
over 9 over y minus 2y. They might not like this is a fraction within a fraction, a compound fraction.
yeah, so you bring the y out, right?
Well, so you got to multiply everything by y now. That's a fraction. You're going to multiply the top of the fraction by y and the bottom of the fraction by y.
Why aren't you multiplying the other side of the equal sign by one?
Here,
Yeah.
I'm looking at this fraction. You got a fraction. If you multiply the top by a number, you got to multiply the bottom by the same number.
Right, but I thought whatever you do to one side, you have to do the other.
You can, but then you won't do it to this one. You'll be multiplying that by y.
Oh, okay.
Yeah. You can't multiply this and this and that. You know, you can multiply this whole side by y and that side by y. When you multiply this side by y, you're only multiplying the top or the bottom, but not both. But since I have a fraction, I'm trying to clean that. I'm going to multiply the top and the bottom of the fraction by y. And that doesn't change the fraction. 2xy over 9 minus 2y squared. So either do it now or do it later. Still going to do it eventually. Two more from this section, then we'll stop the camera and go to section 3.6 and deal with that. Number 12. X cubed plus y cubed equals 8xy minus 5. There are two questions to that. The first one, find dy dx. Then they give you a point, find dy dx at 4 and 3. So there's two parts to it. Find the derivative first, then find the derivative at that point. Let's find the derivative first. Let's take the derivative both sides. What's the derivative x cubed? What's the derivative y cubed? Y prime you want to use? Okay, I don't mind the y prime. Less writing instead of a fraction. I like that actually. I forgot about that part. One letter versus 4. dy dx. Here's the 8. You have x times y. What's the derivative x times y? We have to use what rule? Product rule. The first x times the derivative the second plus the second, which is y, times the derivative the first. The first times the derivative of the second plus the second times the derivative of the first. Here's the minus sign. What's the derivative of 5? 0. Clean it. 8x y bar plus 8y. I want to solve for y sub prime. Let me bring this to this side. Let me take that to that side. Three y squared, y sub prime, minus 8x y sub prime equals 8y minus 3x squared. Can we factor y sub prime out? So what's y sub prime? 8y minus 3x squared, yep. Good. So that's the first question. Find the derivative. The second part, they want it at 4 comma 3. So now let x be 4, let y be 3. 8 times 3. 24 minus, take the 4 and square is 16. 16 times 3 is that 48?
Yes.
Y squared, 3 squared is 9, times 3 is 27. 8 times 4 is 32. That's a negative 24, I think, on the top. And what do we got on the bottom? Is that a 5? Negative 5? So that's 24 over 5. And the last one from this section is number 14. Is your arm tired yet? No?
I just spraying the thumb on my writing hand.
I had a teacher, a Winnick, Musiak. He broke his hand. We were so excited because the guy writes non-stop. He shows up next day, he can write with the left hand as fast as the right hand. I'm telling you, we were devastated, all of us, like, ah! Musiak, one of the best teachers I ever had. Find the slope of the tangent line. The slope is number 14. They want the slope of the tangent line. What does that mean? That's the derivative at a point 2 comma 1. So what's the derivative at 2 comma 1? That's really what they're asking you. Just it looks like a long way of saying it. The problem is 10 minus x y squared equals x cubed. You can leave it like this if you want, or if you want to distribute that first, you can. It really doesn't matter. So if you distribute that, what do you have? 10y squared minus xy squared equals x cubed. I could have left it alone and used the product rule. The first times the derivative of the second, plus the second times the derivative of the first. I'm still going to use the product rule right here. So what's the derivative of 10y squared? 20y times what? dy dx. Done for that piece. Here's the minus sign. I have a multiplications here. That's x times y squared. So it's going to be the first, which is x, times the derivative y squared, which is 2y dy dx, plus the second, which is y squared, times the derivative of the first. What's the derivative of x? 1. What's the derivative of x cubed?
3x.
Yep. So we have 20y dy dx minus 2xy dy dx. While I'm here, let me drag that piece to the other side. This is what? Is that negative y squared? When you distribute the minus sign? When you take it to that side, it becomes what? Positive y squared. dy dx, let's see, 20y minus 2xy, 3x squared plus y squared. What's dy dx? Yep, the right over the left in this case. And now we want it at 2 comma 1. Four times 3 is 12, plus 1. 20 times 1 is 20. 2 times 2 times 1, is that a 4? What do we have, 13 over 16? Yep, 13 over 16. So find the slope of the tangent line at 2 comma 1 means find the derivative at 2 comma 1. Find the derivative, then plug the numbers in.